9, we get given a cubic function and then asked some questions about it. Is they give us a sketch of the graph as well. It looks something like this. That's the cubic function, and the equation for that, f of x equals x cubed plus ax squared plus bx minus 2. That's the equation for this curve. We also get told that the point P lies on the curve, and that's negative 1, negative 1. We get told this other point here is R, and this is obviously the origin. Now, question 9.1 asks the following. Show that A equals 1 and that B equals negative 1. So we have to show that A is 1 and that B equals negative 1. How will we do this? Well, if we look at that equation, we see there are two unknowns, an A and a B. So we know we'll need to find two equations to solve this simultaneously. You know, the one equation is fairly straightforward that we can do. We can just substitute this point into that equation. That'll give us one equation. So let's do that. We'll say negative 1 is our y value, and 1 is negative 1 is our x value as well. So negative 1 equals negative 1 cubed plus a times negative 1 squared plus b times negative 1 minus 2. And we'll simplify this a little bit. So negative 1 cubed is negative 1, minus 2 is negative 3. That'll be our number. So there's negative 3, take it across to that side, and we'll get negative 1 minus negative 3 will give us 2. Equals negative 1 squared is 1a, and negative 1 plus times b is negative b. So that's our first equation. We'll call that number 1. Now, another equation would be if we had another point on this curve, we could substitute that in, but we don't have another point on the curve. But we do know that P here, that's a turning point. What do we know about turning points? We know that the gradient at that point is 0. And how do we find the gradient of a curve or any line? We use differentiation. So if we find the derivative of this curve and put it equal to 0, the answer to that when we factorize it or solve for it will be x equals 1, negative 1. So let's do that. We know that the f prime of x, or f prime of 0 rather, no, f prime of x equals, okay, let's differentiate this. X cubed becomes 3x squared, ax squared becomes 2ax, and bx becomes b. Negative 2 falls away, it becomes 0. The gradient of any constant is 0. Okay, now if we set this equal to 0, this part equal to 0, we find that the x value will be negative 1. Okay, so we know that if we set that equal to 0, then our x value will be negative 1. Okay, q squared plus 2a times negative 1 plus b. And we simplify this, so we have the variables on one side, numbers on the other. We get negative 1 squared is 1 times 3 is 3. Take it across, it becomes negative 3. Equals negative 1 times 2a is negative 2a, and b remains b. So negative 2a plus b. So that will be our second equation. Now we can solve these two equations simultaneously. Okay, so let's rewrite those. We've got 2 equals a minus b. That's our first equation, and we've got negative 3 equals negative 2a plus b. Negative 3 equals negative 2a plus b. That's our second equation. Okay, now we're going to just do simultaneous equations on these. Now you can do substitution if you like, but I'm just going to use elimination because I find that it's a little bit quicker most of the time. So how will we do that? Well, we see the coefficients of b are the same. One is negative 1, one's positive 1. So if we add them together, they'll cancel out. So we're going to add these two equations together. So 2 plus negative 3 gives us negative 1. And a plus negative 2, a gives us negative a. Therefore we have that a equals 1. And now we can substitute this 1 equals a back into either one of these equations. Let's put it in the top one. So 2 equals a, which is 1 minus b. And therefore b, if we take the 1 across here, it becomes 2 minus 1 is 1 equals negative b. And therefore negative 1 equals b. There you go, we've proven that a equals 1 and b equals negative 1, just as the question asked. Okay, next question, 9.2. Hence or otherwise determine the x-coordinate of r. As you can see, r is the other turning point. So we just have to know that the gradient at that point again will be equal to 0. So again we'll set f prime of x equal to 0. And we calculated that f prime of x was equal to what? So that was equal to 3x squared plus 2ax plus b. 3x squared plus 2ax plus b. But now, instead of a and b, we've got these values to put in there. So let's do that. 3b was negative 1, 2a was 1, and b remains, b is negative 1. Okay. So then, apologies, I substituted into the x there. F prime of x, let's do that again, equals 3x squared plus 2 times a. 2 times 1 is 1, so that becomes 2x, and b is negative 1. So that's our derivative now. We put that equal to 0 to solve for the two values of the turning point. And that gives us 0 equals 3x squared plus 2x minus 1. And we can factorize that. So 0 equals, as this is a trinomial, it would be 2 brackets in the factorization. 3x times x gives us 3x squared. Now which factors of negative 1 and 3 when added or subtracted will give us a value of positive 2? It will be 3x plus 1 will give us 3x. Then minus 1x will give us the plus 2x. Okay, so those are your values. So now we know that either 3x minus 1 equals 0 or x plus 1 equals 0. And this implies that x equals 1 over 3 if you solve for x, and this one that x equals negative 1. Now we already have this one, that's our p-value, x equals negative 1. That's this turning point. So obviously the value for r would be the other one, which is x equals a third. But they've asked us the x-coordinate of r only, so that's all we need to know. If they asked us for the total coordinate of r, we would have to substitute this x equals a third back into the original equation to find the y value. Okay. Question 9.3, and the last one for this question. Write down the coordinates of a turning point of h if h is equal to, say h of x is equal to 2 f of x minus 4. Yeah, there's a couple of ways we can look at this one. We can just have a look at what this transformation would mean and adjust the turning point accordingly, which I think is the easiest way. Or you could take the whole equation of f of x and do the transformation on it and then solve for the new turning point. But let's take the easy way. P we know is negative 1 and negative 1, and that's a given, so we know that's correct. You could also use the point for r, but we would rather use the point for p, which is given, so we know we didn't make any mistakes in getting there. And now we just apply 2 f of x minus 4. So what does this mean? F of x is a y value in the equation. So if we double the y value and then subtract 4 from it, that's our new y value. So let's apply that to p. So if p was x and y, it now becomes x and 2y minus 4. Okay, so from negative 1 -1 now becomes -1, x stays x, and the y value becomes 2y, so 2 times -1 is -2, minus 4 is -6. There you go, that's it for question 9. Question 10 is a short word problem question, although luckily in this case you don't have to set up any equations for yourself, which is usually the most difficult part in word problem equations. Okay, I'll read this to you, but I suggest you read it on the question paper as well. An industrial process requires water to flow through a system as part of the cooling cycle. Water flows continuously through the system for a certain period of time. The relationship between the time t, from when the water starts flowing, and the rate r, at which the water is flowing through the system, is given by an equation. So they give us this equation. The rate r, at which the water flows through the equation, is given by r equals -0.2 t squared plus 10t, and t is our time in seconds. R is the rate. Okay, 10.1. After how long will the water be flowing at the maximum rate? Okay, maximum rate, maximum or minimum, we use differentiation to find those turning points. In this case we can see the highest power is at 2, so it's a square, that gives us a parabola. And we can see it's a -a value in this parabola, which means it's this shape. So obviously the maximum rate would be at that turning point. And the turning point has a differentiation value of 0. I mean, a gradient of 0. So if you differentiate and put the answer equal to 0, that'll give you your x value at that point. And that is our time, and this is our rate. Okay, so let's do that. All we need to do is differentiate r. So differentiate -0.2 t squared multiplied by 2 gives us -0.4 t, and 10t, if you differentiate that, just becomes plus 10. And now we want to set this equal to 0. So this is the gradient. We want to find out where the gradient is 0. So 0 equals -0.4 t plus 10. Move the numbers to one side. We get, so we'll take this whole t value to the other side. So we get 0.4 t equals 10. Divide both sides by 0.4 and we get t equals, this is the same as 2 over 5. So it becomes multiplied by 5 over 2 is 50 over 2, which is 25. And that is your, so 25 seconds. Don't forget to write in the units. So after 25 seconds, we have our maximum rate of flow. 10.2. After how many seconds does the water stop flowing? Okay, as we can see from this picture here again, this is the rate. So when the rate is either here or here, the rate is 0. It means there's no water flowing through. So that means we have to find the x-cuts. And obviously it cannot be on a negative side. It'll have to be, if there's a negative and a positive answer, it'll have to be the positive, because you don't get something like negative time. So what do we need to do to find the x-cuts? Well, we say in the original equation, 0 equals -0.2 t squared plus 10t. So we have to factorize this. Take it a common factor of 2, t, and then we get -0.2 t plus 10 equals 0. So something times something equals 0 must mean either one of them is 0, as we discussed before. So t equals 0, or -0.2 t plus 10 equals 0. In this case t equals 0, and over here if we solve for t, we get that 10 equals 0.2 t, divide both sides by 0.2, and we're left with 50 equals t. So after 50 seconds, the flow will stop completely, and it starts at 0 as well. So it starts at 0, then it starts increasing in flow, and then at 50 seconds there's no flow anymore. So that's it, and we can see this is symmetrical because the turning point of a parabola has to be midway between the x-cuts, and we see this is true. Between 0 and 50, midway between that is 25 seconds. That's it for question 10.